Welcome to the respiratory system, and this is an introductory to it. We're going to be learning about the structure, the function, and the key processes of the beautiful system that brings that air into our body and gets rid of the carbon dioxide. So the respiratory system is essential for providing oxygen to the body and then removing carbon dioxide, which is a waste product of cellular metabolism. So this presentation should outline the structures, the stages, and the key processes of the respiratory system and what it does. So the function of the respiratory system ultimately is to bring oxygen into the body and send that to the cells, and then it removes the carbon dioxide, which really helps maintain the acid-base balance in the blood. So the vital functions is that it supplies oxygen to the bloodstream to support the cellular activities that happen at a cell basis. It removes carbon dioxide, a byproduct of cellular metabolism that's actually quite poisonous to the body. It helps maintain the acid-base balance in the blood. It filters and humidifies the incoming air, and it supports the sound production via the larynx. So whilst these are the biggest functions of the respiratory system, there are some other subtleties that the respiratory system does help us with. So the structure of the respiratory system. The respiratory system is made up of organs and structures that facilitate the breathing and the gaseous exchange. So we've got the nasal cavity that warms, filters, and humidifies the air that we breathe in. The pharynx and the larynx, they direct the air through a tunnel. The trachea, which is the tunnel. The larynx also houses the vocal cords. The trachea is the windpipe that channels air down here to the bronchi, reinforced with cartilage for stability. Then we've got the bronchi and the bronchioles. That's when we start getting to this kind of level on the structure of the lungs. And they're the branching tubes that carry the air into the lungs. The lungs is the main organ of the respiratory system, and that contains millions of alveoli where the gas exchange actually occurs. So the alveoli that I just mentioned are tiny, thin-walled sacs surrounded by capillaries for oxygen and carbon dioxide exchange. And then we've got the diaphragm and the intercostal muscles, which help facilitate the breathing by creating pressures that changes in the chest cavity. So it becomes a bit more of an autonomous system. Because of that pressure change, it increases our lungs to pull in that air, and then it pushes the air out. So the stages of respiration, we've got first of all the pulmonary ventilation, which is known as the breathing part, the most important part. So that includes inspiration. It's inspirational. So that's the inhalation, and the air is drawn into the lungs as the diaphragm contracts and the chest expands. Okay, so that sucks in that air. And the expiration, the exhalation, is when the diaphragm relaxes, the chest compresses, and the air leaves the lungs. We've then got the external respiration, which is the exchange of gases. So the exchange of oxygen and carbon dioxide between the alveoli and the surrounding capillaries. The third part over here is the transport of the gases. So the oxygen is transported to the body tissues via the hemoglobin in the red blood cells. The carbon dioxide is transported back to the lungs to be exhaled. And then we've got the internal respiration, which is the exchange of gases between blood and tissues. So the oxygen moves from the blood to the body tissues, and the carbon dioxide moves from the body tissues back to the blood. And that continues that circulation as the heart keeps on pumping. That circle happens each and every time there is a pump. So the process of the gaseous exchange, this occurs in the alveoli, the small sacs within the lungs. They're very thin, it's very moist in that lung area, very, very moist in the alveoli. And the amount of capillaries in there is very, very dense because there is a high amount of oxygen coming in and there is a high amount of oxygen exchange, gas exchange required. So the way that it happens at the alveoli, so the oxygen diffusion, so oxygen moves from the alveoli where the concentration is really high into the blood where the concentration is really low. That's a natural exchange that happens where something of high concentration moves to where it's of low concentration. All right, so that happens automatically through the cell wall into the blood. The carbon dioxide diffusion moves again in exactly the same way, but it's the opposite. So the carbon dioxide moves from the blood, where the high concentration is, to the alveoli, where the low concentration is. So it's literally a swaps over because everything is moving from high to low. It's like a natural process that happens without any extra effort that will naturally occur in every cell in our body. If there is a high to low, the the, the soluble, the molecules, the whatever that is going from that solute will move from the high concentration to the low concentration. In this case, we're talking about the gases. So the oxygen moves from the alveoli, the high concentration, to the blood, low concentration, and the carbon dioxide moves in the opposite way from high concentration in the blood to the alveoli low concentration. So the key factors for this gaseous exchange is that the walls of the alveoli are incredibly thin. That allows for that easy diffusion. Also, the alveoli it's like really bubbly, and that's to create a really large surface area so that so much exchange can happen in one place. It's really moist, and that really aids that gas diffusion, and the close proximity of the capillaries to the alveoli. So there's lots and lots of capillaries that are really close to that alveoli, ready and raring to go for that gaseous exchange. So the common misconceptions is that respiration is the same as breathing. And I really wanted to remind you that breathing is part of respiration. Respiration isn't just taking in that air and exhaling the carbon dioxide. Respiration is the whole system of getting the oxygen from the air out here, out into our cells, so that there can be a gas exchange and the oxygen can help with the cellular processes. All right. So it begins with that breathing, and that's very important. And it's a long process. So anything that gets in the way of that process will affect respiration, whether that's affecting the breathing or affecting how well the air is taken up by the blood. If our circulation isn't very good, then the air isn't going to get round the body quick enough. Do you see what I mean? The other thing is that lungs actively pump air, and we don't think let's breathe in, let's breathe out. We do when we're doing breathing exercises, of course, but naturally our breathing happens and occurs because of the pressure changes by the muscles. So again, if there's anything that impacts how well our muscles work in that area, that will impact on our lungs. So say if we had a physical accident where our muscles were hurt, that would really impact on our breathing quite substantially. And we would probably need something to help us create that pressure in and out. So those are a few common misconceptions that I just wanted to get rid of. And in summary, the respiratory system includes the nasal cavity, the trachea, the bronchi, the lungs, the diaphragm. The respiration occurs in stages. So we have the ventilation, we have the external respiration, we have the gas transport, and we have the internal respiration. So the gaseous exchange is critical for oxygen delivery and carbon dioxide removal. And understanding the respiratory system helps us address common misconceptions. You really have to, when you look at the systems, you recognise that it's a whole body system. It's not just the organ that's involved. The organ might be absolutely crucial to it, but it's the whole system. That's something I really want you to remember. As holistic therapists, we are treating the whole. We are looking at the whole body. Any part of that body that isn't working fundamentally at its optimum will cause significant impacts along the way. The quicker we can pick it up, the quicker we can deal with it, the less bad it gets. We can, prevent the severity from recognizing that something is going on and helping. And very much in the early stages, actually, rest is probably the best way that we can help, and by encouraging that rest. So some of the common pathologies of respiratory system is asthma, we've got COPD, we've got pneumonia, lung cancer and bronchitis. So those are the things that should be a good idea for you to look at and add to your portfolio. I hope you've enjoyed.